Detailed overview of soil erosion. Introduction. Soil erosion is the process by which the earth's topsoil is worn away and transported by natural force such as wind, water, or human activities. As a critical component of land degradation, soil erosion reduces soil fertility, undermines agricultural productivity, and contributes to environmental issues like sedimentation and water pollution. Globally, 24% of land, approximately 1.5 billion hectares, is affected by degradation, with soil erosion impacting 1.5 billion people. These documents provide a detailed exploration of soil erosion, including its causes, types, and impact and mitigation strategies. Causes of soil erosion. Soil erosion results from a combination of natural and anthropogenic factors, with human activities significantly accelerating the process. Water, rainfall and runoff dislodge and transport soil particles, particularly on sloped or bare land. Heavy rainfall events intensified by climate change erode 2030 billion tons of soil annually. Wind, in arid and semi arid regions, wind removes fine soil particles, especially where vegetation cover is sparse. Wind erosion affects 28% of global degraded land. Agricultural practices, overtilling, monoculture, and removal of crop residues expose soil to erosion. Intensive farming contributes to 50% of global soil erosion. Deforestation, clearing forest for agriculture or logging removes protective vegetation. Increasing erosion rates, deforestation causes 30% of soil loss in tropical regions. Urbanization, construction and land clearing compact soil and increase runoff, accelerating erosion. Urban expansion and degraded 10% of global arable land since 1975. Climate change, increased rainfall intensity and frequency of extreme weather events driving by a 1.2 degrees Celsius global temperature rise exacerbate water and wind erosion. Overgrazing, excessive grazing by livestock removes vegetation and compacts soil, increasing erosion risk. Overgrazing affects 20% of global grasslands. Types of soil erosion. Soil erosion occurs in various forms depending on the eroding agents and landscapes. Shear erosion, uniform removal of thin soil layers by rainfall or runoff, often unnoticed until significant soil loss occurs, common on agricultural fields. Rill erosion, a small shallow channel canal formed by concentrated runoff, typically less than 330 centimeter deep, prevalent on sloped farmlands. Gully erosion, deep canals over 30 centimeter carved by intense runoff, rendering land unsuitable for agriculture, common in tropical regions with heavy rainfall. Britannica 2025. Wind erosion, Removal of loss. Dry soil by wind, forming dust storms in arid regions, significant in the Sahel and Great Plains. Tunnel erosion. Subsurface soil removal by water flowing through soil pores, common in dispersive clay soils. Bank erosion. Erosion of river banks by flowing water, destabilizing land caps and increasing sedimentation. Impact of soil erosion. Soil erosion has far-reaching effects across multiple domains. Environmental impacts. Soil fertility loss. Erosion removes nutrient-rich topsoil, reducing organic matter by 2050% in affected areas, degrading ecosystem health. Water pollution, eroded soil increases sedimentation in rivers and lakes, rising turbidity and harming aquatic life. Sedimentation affects 4%, 40% of global water bodies. Carbon release, eroded soil release stored carbon, contributing to 1.1 GTC annually, amplifying climate change. Agricultural impact. Reduced productivity, loss of topsoil, decreases crop yields by up to 50% in severely eroded areas, threatening food security for 1.5 billion people. Increased cost. Farmers spend $44 billion annually in fertilizer and irrigation to compensate for eroded soils. Societal impact. Food insecurity. Reduced agricultural output exacerbate langurs, particularly in sub-Saharan Africa, where 30% of arable land is degraded. Economic losses. Soil erosion cost global economies $400 billion annually due to lost productivity and ecosystem service. Displacement. Degradation driven loss of livelihoods could displace 50 million people by 2030 in vulnerable regions. Mitigation and management strategies. Addressing soil erosion requires integrated approaches combining natural and engineered solutions. Vegetative covers, planting cover crops, grasses and trees stabilize soil and reduce runoff. Agroforestry can reduce erosion by 90% on slope lands. Conservation tillage, no-till or reduced tile farming minimize soil disturbance, preserving structure. Adoption in the US reduced erosion by 43% since 1982. Tracing and contouring, shaping slopes into traces or following contour lines reduce runoff velocity. Terracing cuts erosion by 5080% in hilly region. Windbreaks, planting trees or shrubs as barriers reduce wind erosion in arid areas. Windbreaks protects 20% of US farmland. Sustainable land management, crop rotation, organic amendments and integrated pest management enhance soil health. These practices could restore 700 million hectares by 2030. Erosion control structure. Check dams, sealed dams and gibbons trap sediments and reduce runoff. These are effective in 60% of gully erosion cases. Policy and education. Implementing regulations like the US conservation reserves programs and educating farmers on sustainable practices, reduce erosion rates, global initiatives. The UN Sustainable Development Goal 15 and the Bonn Challenge aim to restore degraded lands, targeting 350 million hectares by 2030. Challenge in addressing soil erosion. Several challenges hinders efforts to control soil erosion. Economic constraints. Implementing erosion control measures cost 1 lakh 200 per hectares, a burden for smallholder farmers in developing nations. Lack of awareness. Many farmers lack access to training on sustainable practices, particularly in low income regions. Climate change. Intensified rainfall and storms driven by a 1.2 degrees Celsius temperature rise increase erosion rates, outpacing mitigation efforts. Land tenure issues. Insecure land ownership discourage long-term investments in erosion control, affecting 20% of global agricultural land. Linkage to climate change and environmental degradation. Soil erosion exacerbates climate change by releasing 1.1 GTC annually from eroded soils, contributing to greenhouse gas emissions. Conversely, climate change intensifies erosion through extreme weather, creating a feedback loop. Soil erosion also amplifies environmental degradation by reducing soil fertility, polluting water bodies, and threatening biodiversity. For example, sedimentation from erosion harms 40% of aquatic ecosystem. Effective erosion control aligns with climate mitigation and sustainable land management goals. Conclusion. Soil erosion is a critical global challenge, degrading 24% of land and threatening food security, ecosystem, and economics. Driven by unsustainable agriculture, deforestation, and climate change, it requires urgent action through vegetative covers, conservation tillage, and policy support. By implementing sustainable practices and global initiatives, humanity can mitigate soil erosion, restore degraded land, and ensure a sustainable future.